Okay, this is the solution for example 6.4. The question is find the residual enthalpy HR and the residual entropy SR for N-butane gas at 500 K and 50 bar as given by the Redlich-Kwong equation of state. So the first few steps are exactly the same as chapter 3 when you want to solve for the Z, okay, compressibility factor. So first you need to find the value for TC and PC from the appendix, okay, and then you calculate the TR and PR, okay. So TR, you get this value 1.176 and this is PR 1.317, and then you need to find beta and Q. So in beta and Q, there are several parameters that you need to find from table 3.1 in your textbook. For example, this omega, and then the alpha, and then this chi. Okay, so you need to get those values from the table. And PR and TR you got from the calculation above. Okay, so you just insert your values, and you get this value for beta, and this is for Q. Okay, next you need to find Z. So Z in this case is gas, so you need to use the largest root. Okay, so largest root from equation 3.52, this is the equation for largest root. And for Redlich-Kwong, because the value of epsilon is 0 and sigma is 1, this is also from table 3.1. So the equation reduced to this, and then this is after you insert the values. Okay, so now you need to solve this this equation here. So we solve by iteration starting with z0 equals 1. Okay, so this is here, start with 1. So when you insert 1, you get z1. Okay, so this is z1. So you repeat the procedure until the value converge. So at this point the value converge at here. Okay, so this is your answer, z 0.686. Okay, so the next step is the new steps from chapter 6. We need to find I, the parameter I. So there are two cases for I. The first case is when epsilon is not equal to sigma. So in this case we use this, okay, because the second case, epsilon equals to sigma, only applies for van der Waals. Okay, so you use the formula to find I. In this case, this is the formula. Okay, and for Redlich-Kwong, because epsilon 0, sigma 1, so now it becomes this. Okay, and so you just put the value inside and find I. Okay, so this is I 0.1323. Okay, the next step is you need to evaluate the d ln alpha TR over d ln TR. So okay, so this alpha TR, this one does not mean alpha times TR. This is alpha in the function of TR. Okay, so because alpha for Redlich-Kwong is TR to the power of negative 1 over 2. So when you do the ln, you got this, and this is the value for the d ln alpha over d ln TR, negative 1 over 2. Okay, so for HR over RT, now you have all the parameters that you need. So the original equation is okay, this one. So for HR over RT, Z minus 1 plus this d ln alpha over d ln TR minus 1 bracket QI. So you have calculated all this QI, d ln alpha and d ln TR, so you can just substitute the value inside, and this is given by 6.67 equation, and SR over R is given by this equation 6.68. so you just substitute the value, so you get HR over RT is negative 1.0818, and for the final answer HR you need to multiply with R and T, because you have RT here. Okay, so your R is using the 8.314 because this is in SI unit, and then the given temperature is 500. Okay, so this is the answer, negative 4497 joule per mole. For SR over R, okay, also the same step, you just substitute the value inside and you got this negative 0.7853, and the final answer you need to multiply with R, okay, to get negative 6.529 joule per mole per Kelvin. Okay, so this is how you determine the HR and SR.